Welcome back students to the next part of this geometry. So this is a small video and in this we are going to specifically discuss angle bisector theorem. Now this is one very small theorem but important theorem, and that can give you one easy question or that can cost you one question as well. So let's revise this theorem. I believe it was there in school as well, maybe somewhere in 9th or 10th standard. So let's understand angle bisector theorem. So to be precise, there are two parts. One is called as interior angle bisector. So let's understand interior angle bisector theorem first. And if you get this, you can easily remember exterior angle bisector theorem as well, as you can connect the two things, or if you can correlate the two things. So let's come to the interior angle bisector theorem. So if BD bisects angle ABC. So if you have a triangle ABC and in this angle B, or to be precise angle ABC, if BD is the angle bisector of that angle ABC, in that case AD upon DC. Now you can clearly see that what is D? D is nothing but the intersection point on the other side. So AD upon DC. So this side upon this part of the side. So AD upon DC, that ratio will be equal to BA upon BC. So that ratio will be equal to BA upon BC. Now how to remember this? Anyway, this is easy to remember in interior angle bisector, but you will need this for exterior angle as well. So the angle for which we are drawing the angle bisector, so arms of that angle are to be included. So these are the arms of the angle which are nothing but BA upon BC, and that ratio will be equal to the relative parts created by that angle bisector on the other side, or on the third side. So that will be equal to AD upon DC. So this is a simple theorem. Let's have one small question based on this theorem. Let's come to the next slide. So this is a question you have. In the given figure, AD is bisector of angle A. If BD is equal to 4 cm and DC is equal to 3 cm and AB is equal to 6 cm, determine AC. So we have to find out the length of AC. I'm just substituting all the values in the diagram. We are given that DC is 3 cm. So this is 3 cm. BD is 4 cm. We also know that AB is 6 cm and AC is the missing segment or missing side. So we know that AD is the angle bisector. So if you know the theorem, we can say this is the angle which is bisected. So the arms of these two angles are to be included. So if I write that, I can write it as AC upon AB. So I have written this side first, AC upon AB. So accordingly, I should be writing this side first. So you can write in the same way DC upon DB. Are you all getting this? Right? So this is a simple theorem. Let's substitute the things. So we can write it as AC is a missing part, that is X, upon AB is 6, that is equal to DC is 3 and DB is going to be 4. So your X is going to be, if I transfer the 6 on the other side, I get 6 into 3, that is 18 upon 4. So when you reduce this further, this is 4 4s are 16. You are left with 2 after that, and after putting a decimal point, it will be 4 5s are 20. So your answer is going to be X is equal to 4.5 centimeter. That is the length of the side AC. So that's option D. So typically, if at all some question comes, they will look like this only. So this is the question with interior angle bisector. Let's come to the next concept of exterior angle bisector theorem. Now exterior angle bisector theorem, the theorem is very much similar. Even the ratio that we write, that is also similar, but understanding of the diagram is more important. So let's learn it along with the diagram. So if this is your triangle ABC, then we can draw an exterior angle like this. Angle ABE can be called as exterior angle, and if angle ABE, we have to draw an angle bisector for this. Let's say BD is angle bisector. So for that, to find out the intersection point, you have to you have to add some length to that AC, or you have to extend that AC, or you can call it as CA. And in that case, the exterior angle theorem will be written like this, that AB upon BC is equal to AD upon DC. Now, how to remember this? How to connect this with your interior angle theorem? Now, if I draw an interior angle bisector like this, this will be the interior angle bisector. If I draw this over here, and if D is the intersection point, in that case, if this is the angle bisector, and if I have to create the angle bisector theorem for interior angle bisector, for this I can write AB upon BC, that is equal to AD upon DC. Now this is what I had written for interior angle bisector, and if you look at the exterior angle bisector theorem, it's still same. So whatever is valid for interior angle, the same thing will be valid for exterior angle. I hope you can connect the two things, and if you can connect, you can remember it as well. Let's have a question based on this. So with the question, there will be more clarity on the concept of exterior angle bisector. So let's come to the next slide for the actual question. Let's read the question. In triangle ABC, angle EDC and angle ADC are given equal. AD is 6 cm, D is 6 cm, and CB is equal to 2 times C. So you have to find out AB. So I'm just writing what are the things already given to us. We know that AD is 6 cm, so this is 6. We know that DE is given to us as 6 cm as well. So this is a vertical length. We know that is 6 cm. These are the two angles equal, so we can say this DC is nothing but the angle bisector. So just to give you the hint, I'm highlighting a triangle. This is the triangle I'm highlighting, and for this triangle, and to be precise, for this angle, you have this as the exterior angle. So angle ADE will be called as exterior angle, and angle AD is getting bisected. So this is the angle bisector which is intersecting at point C. We are given some information that CB is equal to 2 times C. So CB is equal to 2 times C. So this entire length is CB, which is 2 times C. So if I take C as X, CB becomes 2X, and in turn I can say B is also X. So I hope you're understanding the substitution. So with this, let's understand how we can connect it with the exterior angle theorem. I have already given you that this is the exterior angle and this is the angle bisector which is intersecting at C. So let's understand the further solution. We know that DC is external angle bisector. So B and EC, we already counted that as X. Now, as per the theorem that we know, DB upon DE will be written as BC upon EC. Now, those who have some confusion, those who still have some confusion, I'll give you the hint. Look, if I draw internal or interior angle bisector, and if this is point C, so do you know what we can write for this? We can write DB upon DE. DB upon DE, this is DB upon DE, which is written over here, is equal to, as I have taken DB upon DE first, so that should be equal to BC upon EC, which is written on the right hand side. Now you can understand and recall it, or you can correlate it with the theorem. Now once we have written this, like I'm just removing that interior angle bisector to avoid any further confusion. But I hope you are getting the side. The sides will remain same. Right. So now we have to just substitute the things. So let's come to the substitution. So as far as the lengths are concerned, we can write this. We know that BC is 2x. We know that EC is x. DB, that is something missing. We know that D is 6. So let's solve this further. You get DB is equal to 12 centimeter. Now DB is 12 centimeter. Let's see what the question is asking for. Be alert about the question part. The question is asking you AB. So this is 12 centimeter. We want this entire length AB. So that should be 12 plus 6, that is 18 centimeter. Right? So 18 centimeter, option C is your final answer. So I hope with this exterior angle theorem is clear to everyone. And if at all some question come, it will typically look like this only. I don't see any big variation in this. Fine. So in the next video, we'll be discussing some more other properties of geometry. Till then, bye bye.